enhancing leveling accuracy using double rodding leveling. In this method, we are doing the leveling job twice simultaneously with a little bit of effort. We are doing the job twice at the same time. To explain the method, let's first go to the typical single rodding, which is the typical case when we are doing a leveling run. In the leveling run, the typical case, we start from a benchmark and we do backside and foresight, and then we calculate at every station, we calculate the height of the instrument at setup number 1, for example, and then we take a foresight, we calculate the elevation of point TP1, turning point 1, and then move the instrument to calculate the height of the instrument. We have height of the instrument 2, we take the elevation calculated for turning point 1, and we add backside 2, and we continue foresight 2 and calculate the height of the point TP2, move the instrument again to setup number 3, do a backside for the height of the instrument and foresight for the elevation of the points, and we continue until we reach the final point, which is BM2. Now, in double rod, we would just add one more turning point at every station. So here, instead of having only one turning point, we will add, this is the first turning point, it was just one turning point. Here we will double it, double turning points, and we will add one turning point a little bit next to the other point, like minimum is 30 centimeters in the specifications, but you can have it 1 meter, 2 meters difference between here, the separation between this point and this point. So we have 2 turning points. So when we start the setup number 1, we'll take the backside 1 to the benchmark, and this will be common for the 2 lines. This line, which is we call it the high line and the low line. So you can see the subscript here, it is H and L. We call it high point and low point, high line and low. So this point, which is the turning point, is called turning point 1, H, which is high, and then this point is TP1, low, another point. So physically in the field, we have 2 turning points. And of course, how we do the turning points is like what we learned in surveying. Good points, visible, stable, and the like. We have the specification of these points before. Now, so what we do now, setup number 1, then we turn to the turning points. We take a reading for site 1 for the high point, another reading for site 1 for the low point. And then we move the instrument as usual, use it to the second setup location, and then this time we will take also 2 backsides, one backside 2 and backside 2, one for the high point and one for the low point. And since we have 2 backside points, we will calculate 2 heights of the instrument. One height is through the first backside reading, and the high point and the low point. What would happen in this case? Yes, we will have 2 readings. Now, if there is any error in the first reading, this will be alerted in the second one, and vice versa. So these 2 points, 2 measurements, they will double check themselves, and hence if there is an error, it will immediately be exposed. Now, we continue for the turning point 2, and the same thing, we have 2 turning points at the same or very close to each other, the high point and the low point, and we take 4 sides, and we calculate now the elevation of TP2H and TP2L. Move the instrument again, take 2 back sides, one on the high point and one on the low point, and then we will calculate the height of the instrument at setup number 3, turn the instrument to the turning point 3s, take 2 more readings, and calculate the elevation of point TP3L and TP3H, and then turn the instrument, and then move the instrument to this location, the final location, take 2 backside, calculate the height of the instrument for this reading and this reading, and then we will take the final foresight to the bench mark. So let's see, how do we do the the note taking and the calculations, it is just the same calculations, but it will be done for the first line and the second line. They are like interconnected in a way that they are in the same table, so you have to be careful when you are doing this. So let us see now how to do the note taking, filling the tables from the field. So as usual, we start from the benchmark, we take a backside on the benchmark, and then on the benchmark from which we calculate the height of the instrument of setup number 1. So backside and backside, actually we took one reading for the backside, but we repeat it because we will need it for the line of the high points and the line of the low points. Although they are done simultaneously one after the other, but still they are two independent runs, and we will take the notes at the same time and put it in the same table. So we calculate the height of instrument 1, height of instrument 1. This is the same one. For the setup number 1, it is the same for the high point or the low point, because we are doing just one measurement, the backside one, and we add it to the elevation of the starting benchmark. And then we turn the instrument to TP1H and TP1L. Here we want to take foresight 1 for the high point, and then we come here, foresight 1 for the high point, and foresight 1 for the low point. How to calculate the elevation of TP1 high, this point, and we'll add the height of the instrument 1 we already calculated, which is the height of instrument 1 is common for both of these lines. So it is height of the instrument 1 minus the foresight reading for the high point, and for the low point we will take height of the instrument 1 minus the foresight reading of the low point. So this is the first setup. We move the instrument, we come to setup number 2. We need to calculate the height of the instrument. Here we have 2 points. 2 points, the TP1H and TP1L. So we will calculate the height of the instrument from both points. How to do that? We have to take 2 backsides, one for the high point and one for the low point. So that's why we turn the instrument and we take a backside 2 for the high point and backside 2 for the low point. Then the height of the instrument from the for the height of the instrument to high point, we calculate it as follows. We add the elevation we calculated here for the point to the backside reading of the H, and we add for the height of the instrument in the L from the L point or the L line, we take it ETP1L, which is the elevation of this point, plus. So here we'll have 2 height of the instruments, one from this line for the high line and one from the low line. So now we continue. We have to go back to the TP2s with 4 sides and 4 sides, one for the H and one for the. So we continue here for the lines. We'll continue with foresight 1, foresight 2H and foresight 2L, and then we calculate the elevation of the here the turning points, the new ones, and then we backside to calculate. After we move the instrument to setup number 3, so we need the height of the instrument here, so we take backsides and we calculate 2 separate height of instrument for the position number 3, and then we continue for the 4 sides and calculate the elevations of the 2 turning points 3, the low points and the high point, and finally we'll move the instrument here. We need the elevation, the height of the instrument at this point, so we take 2 backsides, and there will be at setup number 4 we will have 1 height of the instrument for the high point or from the high point and 1 from the low point, and we calculate them using the backside readings and the elevations of the previous turning points. At the end we will take 1 reading to the benchmark 2, and this we'll use it for both of the lines, one for the high point or the high line and the second. So from here we will have elevation of benchmark 2, elevation benchmark 2, and supposedly if we don't have any errors, these should be the same. Of course, at least we have random errors, so this effect will give you a slightly different answers or values for the elevation of benchmark 2. So what are we going to do? We take the average. So we take the average of benchmark 2 and benchmark 2, one from the high point or a high line and one from the low point. And let's see a numerical example. It's just plugging in the numbers. So we have these values. Here are the values of the backside. We had one backside reading, which is 3.74, but we repeat it here. Calculate the height of the instrument, and this is, of course, the given elevation of the benchmark 1. We go into the typical procedure from here to here, and then we continue with the blue. So every color is a setup. So this is the second setup, and this is the third setup. Backside and foresight, including every setup. It will include calculating the height of the instrument and calculating the elevation of the point. So here we have the backsides to calculate the height of the instrument, and here we have the foresight readings to calculate the elevations of the point. Fourth setup, the last one, we take the backside and calculate the height of the instrument. At setup number 4, then go for the foresights and calculate the elevation. Which one? The computed elevation of the benchmark 2. Here it was 851.98, 852.00. So we have 2 centimeters of difference. Take the average, and the average is 851.99. All the times we need to check our computations, mathematics in the table. So we take, let me just clean the board, and then we have to take the summation of backside minus summations of foresight must equal to the last point elevation minus the first point. So here we will take, for this summation, it is for the high point. So the high point summation of backsides of the high point. So this will be this is one backside, second backside, third backside, and fourth backside. Add them together, it will give you this one. And then we will take the low point, this one, and this one, and that one, and that one. So we have, and this will give you this. So we do the checking for each line by itself. This is the H line going through this solid line. Oops. And then we have also another check for the L line, which is the dotted line. Okay, the dotted line, it has these 2 solid parts with it. Now, summation of backsides for the H values, it's here. And then we have summation of the foresights for the same high point or high line. The summation of backsides minus summation of the foresights, this equals this value. Of course, for this value is for the high line, and this is for the low line. But here, what is this? What are these? It is this, which is the last point. It is the benchmark 2 minus the starting point. And this is for the H points. And then we have the last point minus the first. The first point is the same. But we have 2 benchmark 2s for the high line, calculated from the high, and calculated from the L. So in both cases, we have the difference between the backside, summation backside minus summation of foresight equals to the last point minus the first point elevations. And this, so this is okay, the calculations. And here we have also the difference is the same, minus 0.76 minus 0.76. So this is how we do the tabulation, and how do we do the calculations of the double Roding leveling.